video we are going to see how basically the ACs are working. Okay, so here I am going to explain you the central AC as well as the unitary AC. Fine. Okay, so we will start initially with the unitary AC. First understand the meaning of unitary AC. Unitary AC means there will be, let's say, one room. For that particular room you will have individual AC, so there will be a separate indoor unit, as well as for that separate indoor unit there will be a separate outdoor unit. So that kind of AC is known to be the unitary AC, whereas the central AC will have only one uh, air conditioner, or we can say the indoor unit, and through that particular indoor unit basically it is known to be the air handling unit. Through that air handling unit the number of rooms are getting cooled. Okay, so that is known to be the central AC. So unitary AC, simply I can say one room one AC, and central AC, number of room one AC. That is the simple definition of unitary AC and what you can say the central AC. So basically the examples for unitary AC are like you will have the window AC, then we have the split ACs. Okay, these are some known examples I am telling you. There one more is known to be the cassette AC. Okay, so there are a number of unitary AC. So out of that I'm going to explain you the split AC first, how it works basically, because that is nowadays more in use. These are mostly ruled out basically, window AC. Cassette ACs are also used in the industry. Okay, other than these AC there are some more ducted AC for in units. Likewise there are number of units which are used in the industry, which are basically comes under the unitary AC category. Central AC basically you must have experienced the central AC in the malls. Okay, then must be in the offices likewise. So that is the central AC, where you'll have the one AC unit, and through that AC unit number of rooms will be getting cooled. Okay, so that is the central AC. Now I'm just going to explain you how the split AC works basically. Fine. So assume that you have a one room over here. Okay, this is the room which is supposed to be cooled basically, and in this particular room you must have seen there will be one AC plug, that is a split AC mounted over here. Okay, kind of you'll have the construction. Okay, something like this. You'll have the flap over here. Through here the cold air is coming out. Okay, this is the cold air which is coming out. This is the room which is to be cooled. Now this unit is connected to the outdoor unit. Let's say you have the outdoor unit over here. This is the outdoor unit I am keeping over here, assume it. Okay, this is the outdoor unit. Okay, so this I'll name is the ODU, outdoor unit, and this is nothing but the indoor unit, IDU. Okay, so both this ODU and IDU, they are connected with the copper pipe. They are connected with the copper pipe. Now basically we know that in refrigeration cycle there are four basic components of refrigeration cycle. So VCR, vapor compression refrigeration cycle, if I consider, so VCRC, components of VCRC. So the first component is nothing but the compressor, then you have the condenser, then you have the expansion device, and lastly you will have the evaporator. Okay, likewise there are the four components. Now out of this, compressor and condenser, they are basically fitted into the outdoor unit. Okay, they are also known to be the high pressure units. These are known to be the HP units, high pressure units. Expansion wall and the evaporator, they are fitted into the indoor unit basically, and this is also known as the low pressure unit. Okay, so assume that you have the compressor over here. I'm just showing you the schematic basically. This is the compressor. Okay, From compressor you will have the, let's say here you have the condenser over here, something like this, and obviously in front of the condenser you will have the fan, okay, for circulation of air. Now from compressor the refrigerant is coming out, it will be given to the condenser. From condenser it will be coming out and will be given over here, let's say to the indoor unit. Somewhere over here you will have the expansion wall, assume it, you have the expansion wall over here, okay, this is the expansion wall, and then through the expansion wall the refrigerant is coming in and it will be given over here, okay, assume that it is given over here to the cooling coil, and from cooling coil the refrigerant will be again taken back, just a minute, okay, so this will be again taken back over here, something like this, okay, and that refrigerant will be given back and will be connected to the compressor. So this is the outlet of the compressor, this is the inlet of the compressor, okay. So this is the basic cycle. This cycle is known to be the VCR, vapor refrigeration cycle. So this is the compressor, then you have the condenser over here, this is the condenser, then you have the expansion wall, this is the evaporator, okay, this is the coil, basically this is the coil, okay, this is the coil. Now basically what happens, the line which I have shown over here, these are nothing but the copper pipes, these are nothing but the copper pipes through which the refrigerant is flowing, okay, also known as the refrigerant piping, fine. Now here you will have the blower over here, there will be the blower. Now this blower will be used for circulation of air, okay, this is the blower, and I'll just name this is the blower, okay. And then how basically what happens over here, let's see. So here basically there are few openings provided which we cannot see basically uh, from the lower height over here, okay, these are mounted at the height, so we can't see these louvers which are mounted on the top. Now what happens, the refrigerant basically is flowing over here, it goes to the condenser, from condenser it will go to the expansion wall, from expansion wall it will go to the evaporator, and from evaporator it will given back to the condenser, compressor, sorry, fine. Now what happens, the cold air, assume that the cold air is supplied over here through the AC. This cold air will be coming down into the room, okay, it will come down into the room, and then obviously the room is always generating the heat, so this cold air will be coming down, it will absorb the heat from the room, it will absorb the heat from the air in the room, okay. Now because of the absorption of the heat from the room, the cold air becomes warmer and warmer. As you know that the cold air will have the higher density and warmer air will have the lower density. Because of this, the warm air will try to lift up in the upward direction, okay, because of the warming up. Now this is the blower, obviously this blower will have a positive head on the front side and the negative on the back side, so obviously there will be the always suction over here, there will be the always suction over here on the back end side. So because of this suction, the whatever warm air is there in the room, that will try to move in this particular fashion. It will move in this particular fashion. It will come, it will go on the top of this particular AC unit, and here there is a passage provided. Through the passage it will come down. Now that warm air will be passing over the coil over here. It will be passing over the coil. Now what happens over here, because of the uh, air passing over the cooling coil, obviously the refrigerant which is flowing in the evaporator coil will have far lower temperature than this particular warm air, okay. And the because of this temperature difference between the warm air and this particular refrigerant, there is the heat transfer taking place between the air and the refrigerant. So the refrigerant which is flowing in the evaporator will absorb the heat from the air which is coming down, which is flowing over the coil, okay. The air will become cold because it is giving its heat to the refrigerant, and the air is becoming cold, that cold air again will be supplied over here, okay, as a cold air or the supply air. Whereas the refrigerant which has taken the heat over here, it gets warmed up and that refrigerant will be given back to the compressor. From compressor it will be given to the condenser. In the condenser, basically the heat from the refrigerant is rejected to the atmosphere. Okay, so this is how initially the cold air is absorbing the heat from the room. That heat will be given to the refrigerant over here, and from the refrigerant finally or ultimately the heat is rejected to the atmosphere. So ultimately the heat from the room is rejected to the atmosphere over here. Okay, but through the process like from the air to the refrigerant and from refrigerant to the atmosphere, likewise the heat will get rejected. So now this is how basically the unitary AC works over here. So the what you can say, the refrigerant absorbing the heat, air is becoming cold, that cold air will be supplied. Now this cold air again will be taking the heat from the room, gets warm up, and again it will be supplied back over the cooling coil. Likewise this particular cycle will be continuing. So this particular cycle of air basically is known to be the air circulation cycle. The cycle of circulation of air is known to be the air circulation cycle, whereas the refrigerant which is flowing over here is known to be the vapor refrigeration cycle. Okay, so this compressor, condenser, expansion device and the evaporator, these components forms a vapor refrigeration cycle, whereas the air which is flowing over here inside the room is known to be the air circulation cycle. So basically for air conditioning, the room air itself is getting recirculated continuously. However, it happens like that some of the air will be getting exhausted from the room. It will go out from the room through the clearances of doors, maybe windows, likewise. So that air is need to be make up, and that air will be made up through with the help of fresh air. Okay, so there will be some there will be the passage for to this particular ACs provided for the fresh air. So through that passage the air fresh air will be given over here. Okay, so many of the times the installer or the contractors, they do not uh, connect that particular fresh air pipe to the atmosphere over here. Okay, but it is mandatory that it is need to be connected. However, if that is not connected, it won't affect the function, because through the doors or the clearances, most of the time the fresh air is also coming in into the room. Okay, so that is getting mixed up over here. Okay, so this is how basically the unitary AC works. Okay, now we will see how the central AC works basically. Fine, I'll just clear the screen first of all. Okay, fine. Now we will see how the central AC works. Again the same thing. Assume that you have the room over here which is to be cooled. This is the room which is to be cooled over here. Okay, fine. Then you have the central AC. Most of the time the central AC will be kept outside of the room. Okay, it won't be kept inside the room. Then there are, what are the components in the central AC? You will have the filter over here. Obviously there is the filter in the unitary AC as well. Okay, in the split AC as well. Okay, so this is the filter. Then you will have the cooling coil. This is the cooling coil basically. Okay. Then you will have the blower. Then you will have the post filter. Okay, for more filtration. From the post filter, the air will be supplied to the room. Okay, this may be known to be the supply air duct. Duct is a component to carry out the warm and cold air to and from the room. Okay, so this is supply air duct. Okay, now as I explained, the warm air is need to be taken back from the room. Okay, so for that also I need to have the duct, because I'm keeping the AC unit outside of the room. So this particular unit is known to be the AC unit. This is known to be the AC unit, or also you can call this as the AHU. Just have the name. So this is the AC unit, or also known to be the air handling unit, AHU. AHU. Okay, air handling unit. Fine. So this is what the supply air duct. This is the return air duct. This is the return air duct. Fine. So here you have the supply air. The air will be supplied to the room. Okay, this is just for what you can say the representation I am showing. At one point I am supplying the air, and at one point the air is taking back from the room. So this is the return air. Return air is nothing but the warm air basically. Supply air is nothing but the cold air. Okay, that's the difference between these two. Fine. Now this particular cooling coil is further connected to the refrigeration cycle as we have seen previously. So I'll be having one compressor over here. This is the compressor. Then I'll be having the condenser. So compressor condenser forms the outdoor unit. Okay. So from compressor the refrigerant will flow to the condenser. From condenser the refrigerant will go. Let's say I'm having the expansion wall over here. From the expansion wall it will be given to the cooling coil, and from the other end of cooling coil the refrigerant will be taken back and it will be given to the compressor over here. Okay, so this is how the flow of refrigerant takes place. Fine. So this forms the outdoor unit basically. Okay, compressor and condenser. So this is the compressor and this is the condenser. Okay, fine. So this is what the outdoor unit is formed. Here this is nothing but the indoor unit. Now what happens over here? Let's see. Basically what happens when the air is supplied over here, assume that this is the cold air, that the cold air will be coming down into the room. Okay, it will come down into the room. So when the air is coming down, it is absorbing the heat from the room because the room is continuously generating the heat. Okay, and to maintain the room at a specified temperature I need to absorb that particular whatever generated heat is there. Okay, so always this particular supply air or the cold air will be absorbing the heat from the room. Okay, obviously when it absorbs the heat it gets warmed up. Okay, and the warm air will try to lift in the upward direction, so it is assumed that it is going to the return air over here. Okay, obviously to supply and take the return air back I need to have the blower. Okay, so there is the blower over here which will be absorbing the heat, sorry, which will be supplying recirculating the air basically. The blower will be used to circulate the air over here. Okay, it will supply the air on one side, on the back end side will have the suction. Okay, and on the front end side it will have the discharge. Likewise it will work basically. So here the air is taken back, which is the warm air. Now that air will be given over here. Okay, basically this there is one section, okay, where this particular return air is taken back. This section is known to be the mixing section. This is nothing but the mixing section. So in the mixing section basically I am mixing the fresh air as well as the return air over here. So this is the fresh air which I am taking from the outside air, outside atmosphere directly. This is the fresh air and this is the return air. So this is the return air. So these two airs basically get mixed over here in the mixing section, and then it is passing, that particular mixed air is passing over the cooling coil. Now generally the percentage of this fresh air is about 20%, whereas for the return air is about 80%. This is the general percentage. These percentage may vary. Okay? It is not like that we have the 80 and 20% only. If I take a case of operation theaters, mostly this is the reverse case where the return air is only 20% whereas the fresh air is 80%. Fine, so that depends on what application is there, and based on the application basically the air is getting the mixture is getting changed over here. Okay, fine. So this is the return air, which is nothing but the warm air. This is the fresh air, which is again from the outside air. So obviously what happens, the mixing section is nothing but the warmer section or the warmer air is available over here. Now that air, because of the what you can say the fan, that air is passing over the cooling coil over here. That air will be passing over the cooling coil. Now when the air is passing over the cooling coil, obviously in the cooling coil the colder refrigerant is flowing. Okay, because of the refrigeration cycle, because of this expansion device, the temperature and pressure of refrigerant is dropped down. So that low pressure low temperature refrigerant which is flowing in the cooling coil, okay, it will absorb the heat from the warm air which is flowing over the coil, so because of this, because of the absorption of the heat from the warm air over here in the cooling coil, the air becomes cold, and now that cold air will be supplied over here with the help of fan and the supplier duct to the room. Okay, Now that cold air is absorbing the heat from the room, and again it is taken back in the return air duct, and from the return air duct it will be supplied back to the mixing section. Again from this particular mixing section, that warm air is passed over the cooling coil. The heat is getting rejected from the mixed air to the refrigerant. Okay, air becomes cold and the cold air is again supplied over. So this is how the entire air circulation of air is taking place. Okay, warm and cool. Now here the refrigerant is which has taken the heat from the air, that refrigerant will be given back to the compressor. From compressor, the refrigerant will be supplied to the condenser at high pressure, high temperature. Now in the condenser, basically the heat from the refrigerant is given to the atmosphere over here. Okay, so whatever heat absorbed by the refrigerant over here in the cooling coil, that entire heat will be rejected in the condenser to the atmosphere. Okay, now that high pressure, high temperature liquid refrigerant will be given to the expansion valve. In the expansion valve, pressure and temperature of refrigerant drops down. Because of that drop temperature, that refrigerant is able to absorb the heat from the warm air over here, and again this particular cycle continues, which is nothing but the refrigeration cycle. So this is the cycle, is the refrigeration cycle, okay, which happens between the compressor, condenser, expansion device and the evaporator. These nothing but the refrigeration cycle. So this particular component is known to be the cooling coil or the evaporator, you can call anything. So this is the cooling coil. Then you have this is the filter basically. Okay, this is the fan basically, or the blower, fan or blower, anything we can call. This is again a filter. Okay, so compressor, condenser, this is the expansion device. Okay, so these are what the components generally you can find in the air handling unit or the central AC. Okay, so this is how basically the central AC works over here. Hope you understand how the AC works. Okay, it's very simple. Okay, if you have any doubt, you can write into the comment. Okay, I can try to solve those. Thank you very much.